Alright, the last video of Chapter 8, or Section 8.2, is talking about 3D figures, talking about what we've already done with Pythagorean theorem, but using it to find information about 3D shapes. So, rectangular solid, 6 faces. A face is an actual physical side. The left side, the right side, the top, bottom, front, and back. Faces on a rectangular shape are going to have 4 letters. So A, G, E, C. That is the worst handwriting I've ever seen. Let's try this again. A, G, C, A, G, E, C. Remember, you have to name them in order. You could do the bottom, G, E, F, H, and then there's 4 others, top, front, back, and right. I'm not going to waste the time to write all 6 of them. 12 edges. An edge is an actual line, so one of them is BD, right here to here. One is GH, and they're 2 letters. So this line, there's 4 going that way, 4 going up and down, 4 going front to back. Again, I'm not going to list out all 12. And then the 4 diagonals. The diagonals is a line that actually goes through the shape, cuts through the entire shape. Try to picture that in 3D. That is the line going from C to H, top back corner to front bottom corner. You also have GD, you have EB, and you have AF. I think it's important to list out all 4 of those so we're able to see what's really happening there. That's the line going through the shape that you don't see. Think about like a box of Kleenex. It's going from opposite corners through the actual middle of the shape in order to finish that line. A cube is a rectangular solid where all of the edges are congruent. So a cube, I'm going to cheat a little bit when I draw this. A cube looks like this, and all of these sides are congruent. You've all seen a cube before. A regular square pyramid. Okay, a regular square pyramid is a square for a base, so KLQP is a square and it's called the base, which means all of these sides are the same. The vertex is the point where all the other sides come together. That's J. And on the same shape, JM is the altitude. Let's write that a little bit cleaner. Sorry about my handwriting. It is the altitude of the pyramid, and it is perpendicular to the base at the center. So it forms a right triangle, and I'm going to trace that right triangle. JMN becomes a right triangle because JM is an altitude. In addition to that, JN is the slant height. Now, it's a height because it's drawn like an altitude. It forms a right angle. It's perpendicular to one of the bases. And it's called the slant height really just because, honestly, it's slanted. When you look at this picture, it's slanted. And now this, ooh, that's not good. Let's try that again. This becomes a right triangle as well. So you have a couple different right triangles where we can apply Pythagorean theorem to in this picture. So take a look at this box. It's a rectangular solid. BC is 3. AB is 4. CG is 12. I need to find 2 things. We're going to find BH. Let me trace BH in red. And then I'm going to find AG, and AG is in blue. Now, after I drew that, I notice AG is a diagonal and BH is a diagonal, so I actually don't need to find AG because I know that BH and AG are both diagonals. They're going to be the same. So I really just have to find one of the diagonals, and then I know both of them. So if that's 3 and that's 4, I know that DC back here is also 4 and AD is also 3. And I know that all of these sides going up and down are 12. Okay, I'm not going to draw that one. I'm going to look just at HD. And HD is important because it forms a triangle with those three lines, the 2 in green and the 1 in red. This angle back here is a right angle. It's a vertical side connected to the diagonal of one of the bases. In class, we're going to show how this looks 3D so you can actually see it. But when I look here, the bases, they're rectangles, so they're right triangles. We did triples last unit, or last section, so we should have them memorized. 3, 4, and that means this is 5. So now I'm going to take the triangle that's in green and red. I'm going to draw it out here. Now I know it doesn't look like a right triangle, but that's because we're trying to take a 3D shape and represent it in 2D space. HD is 12, DB is 5, and this is actually a right angle. It's not in the picture because it's a 3D shape again. So 5, 12, and 13. That's another triple. So BH is 13, AG is also 13. We have a rectangular solid where the dimensions are 3, 5, and 7. Find the diagonal. So, rectangular solid. Let me draw a rectangle, and let me copy this rectangle. So then this way I can use this shape that is drawn to scale. Okay, and let me draw in these sides. So now we have a rectangular solid, and my goal is to find a diagonal which connects opposite corners. Now I know it also uses, let's put dotted lines here. I'm going to look at this right triangle connecting those two. So this vertical one, let's call that the 7. Let's call it the big side because 7 honestly is bigger than 3 and 5. And let's call these 3 and 5. So now the right triangle in the base, 3, 5, and something. There's no triple that has that. So 3 squared plus 5 squared equals x squared. Let's label this x. Now 9 plus 25 equals x squared. So x squared is 34. X is the square root of 34. So it's not going to come out nicely, but looking at the triangle that's drawn in with purple and blue, I have a side of 7 and a side of square root of 34. So 7 squared plus square root of 34 squared equals, let's call this side y squared. So my diagonal is y, so 49 plus 34, the square root of something, or the square of something that's a square root is just the number on the inside. And 49 plus 34 gets you 83, so y squared is the square root, I'm sorry, not the square root, y squared is 83. So the diagonal y is the square root of 83. And our final example for this section, the square pyramid has an altitude PR and a slant height PS. The perimeter of JKMO is 40, and PK, this side here, is 13. So, since there's a perimeter of 40, that means, oops, that's the 4, that means each one of these is 10, and the back one's 10. I'm not going to label that, but over here, the slant height splits that in half. Each of those are 5. So, find JK. Already did that. That's 10. Find PS. What I want to do is I want to look at this triangle on the outside of the shape. One of the sides is 5. One of them's PS. This corner edge is 13. There's a triple. 5, 12, 13. Now let me get rid of this mark in red so that way we can look at something else. I want to find PR. So instead of that, let me keep erasing. Let me get rid of this purple. I know that this is 12 PS. I know that these are 5. I'm looking for PR. Well, I also know RS. Even though I don't think I know it, I do know RS. Because point R is exactly dead center in the middle, which means it's half of 10. That side is 5. So 5, 12, and let's not answer 13 because 12 is the hypotenuse. 5 squared plus x squared equals 12 squared. 25 plus x squared equals 144. And 144 minus 25 gets me that x squared is 119. So x, or PR, let's change that actually. Let's do PR. PR is the square root of 119, and let's just go ahead and leave it at that.